Assalamualaikum and good afternoon to Dr. Puteri, Dr. Azizi, all the panels and my fellow friends. My name is Puteri and Miss Natasya. My members are Chua, Teng and Haqimi. We are from Group 3, Section 1. We present about our project, Reverse Vending, Recycling. First of all, our concept is reverse vending machine. Reverse vending machine is a machine where people can return empty beverage or containers like bottles and cans for recycling, deposit, refund or reward amount to the end user. This is what makes it a reverse vending machine. The user puts a product in and gets out the monetary value. Our product or our project only accepts the right type of materials. It prevents from using of recycled bins with the built-in waste segregation with recognition system. The machine accepts plastic bottles, aluminium tins and glass bottles from user. Next, our machine comes with a reward system where the users can earn money through recycling according to the amount of solid waste that given by user. And lastly, we use a Bing application to inform the person in charge when the operation of the product is problems, such as coin machine or recycle bins are full, or the coin machine are out of coins. This is what we call the sub-monetary system. Now we go to the problem statement. The problems need to be solved in this project in order to increase the recycling rate of solid waste in Malaysia. We figure out about the suitable technology, which is recognition and segregation system. We use to separate solid waste for an ease of recycling process. The objective of our project is to implement the technology such as sensor and microcontroller in reverse vending machine to recognize the type of solid waste and process them. Then the project is to develop an electronic reward system that gives rewards based on the amount of solid waste that user have recycled. Lastly, to implement a user-friendly system of reverse vending machine.
The details in the slide showing the NABC concept, which is the reason of product is needed for people in Malaysia. So needs. This is the statistic we made for survey in the previous semester, and those numbers are the most of recycled materials. And our product accepts 3 out of 4 of these materials, which are plastic, aluminum, and glasses. We're not doing the paper segregation in this product because it is quite complicated. So technologies such as waste segregation system may help in wrong using of recycled bins, because there are few numbers of waste that detect the color or type of bins and make them throw the waste into the wrong bin. For the approach, next, we apply technologies such as IoT and sensors to recycling operation. They're utilizing the waste segregation system such as plastic, glass, and metal recycling system, as well as self-monitoring system in inverse vending recycle bin. This will encourage people to recycle and give them money as a reward when they have completed the procedure. So next, for the benefits, it gathers the glass in relation to plastic bottles and aluminum cans, which some other products do not. When compared to other products that employ receipt printing system, we are using coin as reward, which is more environmental beneficial. When the recycle bins are full, the person in charge is notified, which is preventing the overloaded recycle bins. Notification to the person in charge is when the number of coins remaining in the machine has decreased, as well as a reminder to make them to refill coins. This will ensure the machine to continue to function properly. Therefore, because buying and separating solid trash is done by machine, labor costs are reduced. For a competitive part, next, currently there are many types of reverse vending machine product on the market. One of the available commercial product is Recycles and Safe, based in Singapore. It collects recycled or plastic drink bottles and aluminum drink cans. So next is available product is DRV1000. It's a reverse vending machine based in Japan that is designed to accept non-refillable PET type plastic bottles and cans. So our project has advantage compared to Recycle and Safe and DRV1000 because it collects glass bottles which is not accepted by the commercial products. Besides that, the product uses coins as a reward for users instead of receipt or coupon. It is more environmental friendly compared to the commercial product. So thank you.
Good morning everyone, I am Chua and I will present about the design of our project prototype. So the picture here is showing our project prototype without the outer shell, so we can see the mechanism inside the project. So the white circle here is a place for the user to insert the material they want to recycle to the machine. And we have 3 recycle bins in the machine. One is for glass, one is for plastic, and one is for metal. And below the material inserted by user, there will be sensor for recognition of solid waste type and mechanism for the separating of the solid waste. We have coin dispenser system in the machine that dispense coin to the user as the reward of recycling. On the machine, there will be two LCD screens. One will be showing the material detected by the system, and one will show the reward accumulated by user in the system. And we have two buttons. One is the stop button that user can use to check out the reward accumulated in the system after the recycling process. Another will be a start button used to submit the material to the machine. The system of our project can be divided into two main parts. One is the recycling system that accesses solid waste from user and giving rewards to the user. Another one will be self-monitoring system that checking space in the recycle bin of the machine and coins remaining in the machine. First, we will talk about the recycling system first. So the recycling system will detect the type of solid waste material inserted by user to the machine based on the reading of the sensor in the system. After the user presses the start button, the solid waste will be sent into respective recycle bin and rewards will be accumulated in the system. And user can accumulate more rewards in the system by inserting more materials into the machine one by one and check out all the rewards accumulated in the system by pressing the stop button. So for the recycling system, we are using Arduino Megat board as the processor. There will be infrared sensors, inductive proximity sensor, and capacitive proximity sensors for solid waste recognition. User can control the process of the system using push button, and materials detected by the system and rewards accumulated in the system will be displayed on the LCD screen on the machine. And solid waste will be sent into recycle bin in the machines by servo motors and DC motor controlled by L298N motor driver. And lastly, the reward for the user will consist of 10 cent and 20 cent coins dispensed by the servo motors. Because of the limit of the video length, I will not explain detail about the sensors for material recognition. But for plastic, metal, and glass insert to the machine, we do have unique sensors reading for them. And the material that cause different combinations of sensor reading other than plastic, metal, and glass will be rejected by the machine, as shown as in this table. And for our system, the reward for each plastic bottle recycled will be 0.7 cent. This value is for demo only and can be modified in the coding for our system. This video will demonstrate a reward of 0.7 cent accumulated in the system after a plastic bottle is sent into the machine, as shown as the LCD below here. And this video will demonstrate how a plastic bottle will be sent into recycle bin by servo motor. This video will show how an aluminum tin is sent into recycle bin, and after the aluminum tin has been sent into the recycle bin, there will be 5 cents of reward accumulated in the system, as shown as the picture beside the video here. And this video will show how a glass bottle will be sent to recycle bin, and a reward of 0.5 cents will be accumulated in the system after the glass bottle has been sent into the recycle bin. This video will show how the machine rejects an invalid material. We will take an onion as an example. This video will demonstrate how user can get a reward of 30 cents after recycling the materials. 10 cent coins and 20 cent coins will be dispensed by the machine as reward of recycling after the user presses the stop button. And that's all for the recycling system. The next part will be the self-monitoring system of our machine. So for the self-monitoring system, the system will check whether the recycle bin in the machine is almost full or the 10 cents or 20 cents coin remaining in the machine have become less or not. And if the coins remaining in the machine have become less or there are not much space left in the recycle bin, notification will be sent to person in charge. And if there are no action taken by the person in charge, the system will stop operating when the recycle bin in the machines are full or no more coins remaining in the machine. And for the self-monitoring system, same as just now, we are using Arduino Megat as the processor. And internet connection, we are using ESP32 development board, and we are using Bing apps to send notification to the person in charge. And for coins detection in the machine, we are using infrared sensor and we are using ultrasonic sensors to detect the space left in the recycle bins. So for ultrasonic sensor for detecting the space left in the recycle bins, the ultrasonic sensor will be placed at 4 cm above the recycle bins, and the height of the recycle bins will be 40 cm. If the recycle bin is 7% full or only 30% of space remaining in the recycle bin, distance between the sensor and the waste in the recycle bin will be less than 13 cm. And notification will be sent to person in charge in this case. And if the recycle bin is full, distance between the sensor and solid waste in the bin will be less than 4 cm. At this time, the system will give notification to the person in charge and stop operating to prevent the recycle bins in the machine from overload. So this video will show notification sent to person in charge when a plastic bottle detects in a distance less than 16 cm from the ultrasonic sensor. We are assuming that the recycle bin is 70% full, so that the distance between sensors and plastic bottle is less than 16 cm. And now we will assume that the recycle bin is full, so the distance between the sensor and the plastic bottle is less than 4 cm. And notification will be sent to person in charge. The difference with the result just now is the machine will stop operating as shown as the LCD screen here. And actually we do have recycle bin for aluminum tin and glass bottle, but for saving the time I will just demonstrate for the recycle bin for plastic bottle. The concept is the same for another two recycle bin. And next, in this project we are using plastic cone to hold coins in the machine and infrared sensor to detect the presence of the coins in the machine. To save the time, I will just demonstrate for 10-cent coins in the machine, and the concept is actually the same for 20-cent coins. This video will show the notification that sent to the person in charge when 10-cent coin in the machine is considered almost finished when the infrared sensor points to the middle of the cone. The infrared sensor with red LED here cannot detect the presence of the coins. So I will manually discharge the coins in the machine to a lower level so that the infrared sensor cannot detect the coins, and a notification will be sent to the person in charge. Next, I will dispense the coins until it is very close to be finished. And a notification will be sent to a person in charge, and the system will stop operating because the coins remaining in the system may be not enough to be rewards for users, so the system must stop operating. And that's all from me. I will pass the next part to my teammate.
Thank you, Chua. So now I'll be presenting sources of error. The first error will be sensors reading for different type of materials are not 100% correct. For example, the infrared sensor that should not detect transparent materials such as plastic and glass may give some wrong output because the surface of material is not smooth enough to have a lower reflection rate of infrared light. So the second one will be ultrasonic sensors that used to detect space left in the recycle bin is also 100% correct. It may have some error due to the different angle of ultrasonic wave reflection that reflected by a solid waste, because the solid waste may have some random position in the recycle bins. So these errors can be solved by potential solutions. The first one will be solved by applying the artificial intelligence technology such as convolutional neural network (CNN), which have the image classification function to have a better result of solid waste recognition. The second error can be solved by using more ultrasonic sensors to detect space left in the recycle bins. So if the noise and measurement errors from the sensors are independent and have zero mean, then multiple sensors will improve the results. Since errors tend to cancel out each other, the number of sensors increases. So for the conclusion, our aims of this project have been achieved. The microcontroller or Arduino and sensors have been implemented, which is an IoT-based project. So a user-friendly reward system that gives rewards based on amount of solid waste user recycled had also been developed. And as for our future scope, it includes applying more advanced sensors or AI technology for a better accuracy of solid waste recognition and also smarter system. So that's all from us. Thank you.